sure this works, and that's okay, this happens sometimes. There's a... Hey everyone. I'm excited to be talking to all of you today about building for the web. And what a great time to be talking about the web because, as you probably heard, earlier this year, we actually celebrated a big anniversary. That's right. The web turned 10 years old. Tim Berners-Lee shared his vision for the World Wide Web in a March 1989 paper titled Information Management, a Proposal, which his boss at the time heralded as vague but exciting. Accurate. And he said this. He said, "The dream behind the web is of a common information space in which we communicate by sharing information. Its universality is essential. The fact that a hypertext link can point to anything, be it personal, local, or global, be it draft or highly polished." And he worked on this idea at CERN for the next few years, and in 1993, we all got to play along with the release of the free Mosaic browser. And it's been a wild ride in the years since then, and of course, now there's tons of websites, new experiences and ideas, and companies built around the web, many I'm sure you've heard of, or I don't know, maybe even work for one. And the browser wars have begun. In just the last couple of years, we've gotten to try a bunch of new web browsers, so you can be a webmaster no matter what operating system you use. And these browsers have been making sure that the web keeps getting more and more powerful, and over the last couple of years, we've seen the introduction of JavaScript and CSS, plugins that let us do new kinds of things like flash animation, and support for future experiences like mobile and virtual reality devices. All of this, and the market seems like it couldn't love us more. So today, I want to share some highlights of the new technologies that have made all of this possible, where we are now, here in 1999, and a glimpse into the future of the web. But first, let's start with the basics. What is the web, and how does it work? Well, a web page is just a normal file. It's a rich text document written in HTML, which is the language of the web, and it contains Tim's clickable hyperlinks that refer to other web pages. And these hyperlinks come in the form of a URL, which has two important parts. The first part is the website, and the second part is the web page. And with a little bit of magic, your browser finds the actual physical computer also connected to the internet for that website, and then asks it for the requested web page. That computer runs a piece of software called a web server, which translates the requested web page to an actual file stored on its file system. It opens that file and sends it back across the internet to your browser using a protocol called HTTP, and this is amazing. But over the last couple of years, we've seen an evolution from serving static files or websites to dynamic programs or web applications. And this lets us make totally new kinds of experiences where the program is being run not on your own computer, but on the web server. And this evolution started with CGI. CGI is both dead simple and super clever. It extends what a web server can do beyond just reading files by saying if the requested file is within a certain directory, and we usually use CGI bin by convention, then that file is a program. And rather than just opening the file, it executes it with a handful of environment variables set from the HTTP request, and then it sends the program standard out back to your browser over HTTP. And this is so cool because literally any program can now be a web application. It could be anything from a shell script to a complex compiled C++ program. Of course, doing anything other than simple tasks is pretty annoying in a shell script, and C++ takes years to master and about as long to compile. Scripting languages like Perl are a great compromise and have become pretty popular with CGI, but Perl wasn't really designed with the web in mind. And here, PHP has really taken off. PHP was created a couple years back in 1995, but it really got interesting to the web community last year with the release of PHP 3. It's an open source programming language, and currently the best way to get started for the web. Now, I say programming language because its creator said that he never really intended for it to become a programming language, though it definitely is Turing complete. It's become really popular since it's the first language built for the web. Its original goal was to process web forms and generate web pages, and it does both of those things really well. And PHP feels revolutionary because it's blurred the line between files as web pages and programs as web applications. For instance, any typical HTML file is actually a valid PHP program. Now, this one doesn't do anything interesting yet. It's more web page than web program at the moment, but we can insert a PHP tag, and now we're in application land. So for example, we can access some state from a submitted form or a cookie, use that to query our database, and then go right back into HTML with fresh data interleaved. And part of why I like PHP so much is it's super easy to learn once you know HTML. You can incrementally include dynamic logic into your existing HTML files, and it scales up to everything you could do with Perl. And it's also free and open source. And part of what I've recently heard called the LAMP stack, which stands for Linux, the free and open source operating system, Apache, which is a free and open source web server that supports CGI, MySQL is a new free and open source database, and then of course PHP. These are all the tools you need to build and serve web applications. And if you're not too familiar with open source software, this might not sound like a big deal, but it means that PHP and the rest of the LAMP stack are constantly improving from the web community's contributions, and anyone can use it without payment or licensing concerns. In fact, I predict that the recent excitement around the web will inspire a future generation to learn to program, and PHP and the LAMP stack will make it easy to do so. And as we look ahead, we can reflect back to Tim's dream. There was a second part of this dream too, dependent on the web being so generally used that it became a realistic mirror, or in fact the primary embodiment of the ways in which we work and play and socialize. That once the state of our interactions were online, that we could use computers to help us analyze it, make sense of what we are doing, where we individually fit in, and how we can better work together. And this second part has yet to happen, which makes me wonder, what will the web look like in 10 or even 20 years from now? Okay, before I get too far into all this, I should introduce myself. My name is Lee Byron, and I lead web engineering at Robinhood, where we're democratizing access to our financial system. I'm one of the creators of GraphQL and the director of the GraphQL Foundation. I was also an early contributor to React, Relay, and other software from Facebook, and I'm responsible for a bunch of other open source projects you might have heard of, like TestCheck and Immutable.js. And I'm actually particularly thrilled to have been invited to speak to all of you here at ReactConf because this conference holds a special place in my heart. Because it was at ReactConf 4 years ago where I first shared my work on Immutable.js, and my teammates shared a first look at GraphQL. Both projects have grown quite a lot over the years and have allowed me personally to build a relationship with our open source community. And no, I'm not actually a time traveler, just occasionally detached from reality. I'm fully aware that the current year is 2019, which means that we actually just recently celebrated the proposal for the web's 30th anniversary. And that means that our open source web developer community is well over 20 years old. And it's fun for me to look back on 1999 because that's when I first got involved with the web and taught myself to program by learning PHP and, building Pokemon fan sites with the LAMP stack. And in the decade after 1999, the web and really PHP exploded in popularity and relevance. The fact that it was free to use, easy to learn, and scalable led to a new post-bubble wave of companies built with LAMP, including some current giants. Wikipedia in 2001, WordPress in 2003, and Facebook in 2004. And while PHP gets a lot of well-deserved criticism, it's still relevant and probably way more popular than you think. Today, over 80% of websites are still powered by PHP. In fact, 30% of the web alone is specifically powered by WordPress. This is pretty wild. And I spent the last 10 of the web's 30-year history working at Facebook, where I saw the evolution of PHP, LAMP, and complex web apps. And what's been most fascinating to me is that now, 20 years later, the programming model and mental model of the web feels largely the same as it did back when these tools were first introduced. Of course, at the same time, we've tackled growing complexity, have built far richer experiences, grown our community 1,000-fold, and scaled to billions connected on the web. And I see a pattern behind this progress, a relationship between three kinds of advancements: better and more powerful abstractions, clear and more expressive syntax, and an improved and refined mental models. In fact, these three influence each other in a sort of loop. We build better libraries and abstractions, which unlock new capabilities and better performance. We introduce new programming patterns, APIs, and ultimately new syntax into our languages to better express ourselves in terms of these abstractions. And that creates clarity, which lets us improve our mental models, how we think about what we build. So today, I want to illustrate this process through a handful of stories and specific examples I saw unfold at Facebook across three problems we've all become familiar with: rendering views, managing state, and fetching data. This is all going to sound familiar because we've heard about it all day. I want to start with rendering views because it's so much of what we focus on as front-end engineers, and it was also PHP's killer feature. PHP really meshed well with the mental model of a web app as a mix of a dynamic content interwoven with static content written in the lingua franca of the web, HTML. And it kicked off this era of the template language, and more followed. There was embedded Ruby, or ERB, in 2004, and mustache templates in 2009, and plenty more. But what these did is that it made it really easy to start with static content and then introduce dynamic values over time. But as you need to build anything complex, you quickly realize the need for full Turing-complete logic, which means these simple template languages either evolved into their own weird programming languages like PHP, or they remained crippled and limited in use like mustache. And even templates with rich logic remain difficult or awkward to modularize or reuse without relying on global variables or just kind of losing most of the benefits of the template syntax. And then there's security, which templates often leave totally up to you. So naive, simple-looking PHP usually suffers from critical SQL injection or cross-site scripting vulnerabilities. And these, in particular, were constant thorns in the side of early Facebook. So to resolve these issues, Facebook built a framework called UI Component. It's funny how this is now kind of a general term. UI Component was heavily inspired by MVC frameworks at the time and the browser's DOM API. So for example, a button might be called UI Button Component, which would instantiate or subclass a UI component. To use this, you would instantiate one with new. You could configure it with a chain of method calls, add children UI components, client-side behavior with a DOM-inspired API, and then call render to get the complete resulting HTML. This solved all of our problems with templates. Now, building a UI was just code. No need to invent a new Turing-complete language. We have an API designed for modularity and reuse. And importantly, what we're building here is actually a tree of UI component instances rather than a string or a stream of concatenated strings. So it's much easier to systemically solve security issues by automatically escaping content correctly based on where it appears in the page, and then always including CSRF tokens and forms, even if you don't know what that is. Basically, security issues solved. Reuse also led to a standard component library, which improved product design consistency. And this all sounds really great. Well, one huge downside was every time we refactored a bit of code from templates to UI components, we just couldn't shake this feeling that the new code was worse. It was more verbose and harder to read, and there's definitely a reason why people prefer to write HTML over directly using the DOM APIs. So luckily, meanwhile, there was actually the Skunkworks project underway at Facebook to rewrite the site from scratch in an effort to achieve better performance and shed technical debt. This was, of course, a terrible idea that did not work out at all and probably should not be tried again. But much like the current effort we heard about earlier today, this effort yielded a ton of super interesting new technologies and ideas, one of which was an extension to PHP called XHP. XHP introduced an XML-like syntax to PHP inspired by the ill-fated E4X JavaScript project. However, unlike E4X, XHP did not try to add any new runtime behavior for working with XML. Instead, XHP was just syntax sugar atop instantiating typical PHP classes. It made it way easier to describe a tree structure of class instances, and it was basically just as easy to read as HTML. This was a perfect match for UI components. The implementation details remained largely the same, but the syntax returned what we loved about templates. Though now we actually had the added benefit of catching errors, like missing closing tags as syntax errors at development time, rather than a broken view or invalid HTML in production. So, quick show of hands. Remember those HTML validator apps that would check your site's markup for errors? Has anyone used one in the last year? Holy shit, no hands. Neither have I. I haven't used one in years. This problem went away. So, the better abstraction of UI components with the better syntax of XHP further clarified our mental model of building modular UI by defining them in terms of other modular UI. So this allowed us to replace an imperative, mutable DOM-style API with a more declarative, functional API. So you may or may not have heard of XHP before, but even if you haven't, you're probably hearing all this and thinking, JSX. Well, you might not know this, but the initial versions of React did not include JSX. The original author of React, Jordan Block, had been working on the ideas behind React before he even joined Facebook. And the idea to change the syntax of the language, along with introducing a library of code, was just not something on his mind at the time. However, as other front-end engineers at Facebook first started to see React, they immediately responded with skepticism. Their mental models had already been shifted by XHP, and it wasn't until introducing JSX that React started to get adopted within Facebook. So imagine our surprise when we open-sourced React in 2013, and people hated it. Specifically, they hated JSX. Y'all were mean. So Facebook engineers had already adjusted their way of thinking about developing UIs, thanks to XHP, but it would take another couple of years for the rest of the web community to come around to JSX. And I think this refinement of abstraction, syntax, and mental model continues with post-React UI libraries like Vue and Svelte. These take it full circle back to the original compelling idea that any bit of HTML is also a valid component. And this feels familiar in a way, like the simple PHP code from 1999, where any HTML was also valid PHP. So early web apps actually used very little JavaScript. Really, the first 15 or so years of the web featured applications with an enviously simple model of managing state. Load a page, click a thing, which loads another page, or maybe you submit a form, which again loads another page. And the programming model for interacting with state over time in this pattern was also simple. Read a form value, or maybe a cookie, update some database state, write a cookie, and then write some HTML. And importantly, PHP apps were not treated as long-running stateful services. Each request starts with a clean slate. Each URL route is associated with a different PHP file to be run, further simplifying routing and state management. It was a novel and unique runtime that we haven't seen that many other examples of until actually fairly recently, where now we associate these properties with serverless, Lambda, and Next.js. And all of this was really the OG one-way data flow for UIs. Of course, this means that every state transition is a full page load. And in 1999, that happened on a dial-up connection, which was painfully slow. It also doesn't allow for any rich client-side or event-driven apps like chat. And Facebook Chat was the predecessor of Messenger and was really the first client-side heavy JavaScript experience on Facebook. It was built in 2008 and followed the well-established MVC pattern at the time. And mind you, this was 2 years before Backbone.js. But for years, the same bug kept popping up over and over again. We called it the zombie notification. Something on Facebook would light up, like you had a message, and you'd go to click on it, you'd be excited, and then nothing, no new message from you. And if you caught his lightning talk earlier today, you know that this was actually one of the first projects that Adam Wolf, my longtime manager, worked on when he first joined Facebook. He's now VP of Engineering at Robinhood, where I also work, so you guys should all come join us. We're a fun crew. But really, what he wanted to do first was just kind of better understand what exactly was causing this problem in the first place. And chat had no automated tests, and was actually pretty difficult to test because it relied on subscribing to all these various event streams that came from all these different sources. And that led us to build a new kind of JavaScript test framework with mocking as a first-class concept, Jest. So we were actually using Jest at Facebook for almost 4 years before we open-sourced it. And so with tests in place to catch regressions, we now better understood the problem. Events that resulted in updates to the chat UI could come from server-pushed events, metadata in a page transition, or people just directly interacting with chat. And then chat itself also appeared in at least 3 places. There's the messages view, there's the chat bar, and then the notification icon in the top corner. And each of these different views had their own logic for handling events and keeping themselves up to date. This was just impossible to keep track of in your head, and it led to repeated inconsistencies because of basically just missing edge cases in the code. So the solution was to rewrite chat with a new architecture. They took the mental model of simple server-side state, but implemented it all in client-side JavaScript. Any event that could alter state changed from an event emitter to instead be represented as an action. And an action is just a declarative description of what should change. This declarative action was then dispatched to a store, much like you would send a post request to a simple stateful web server. And they called this architecture Flux. Of course, for this simple web server style approach to be complete, the result of dispatching that action should be similar to what happens in response to a web request. The entire page should be replaced with the new response that includes the results of that change. But that would be very different from how we were building client-side UIs at the time. If you looked at the callback for a new message event, it would be directly constructing new DOM nodes and calling a pen child on the chat window. And changing from this to replacing the entire view wouldn't necessarily be better because it could be slow, it would flicker the UI, you would lose things like your scroll position or whatever you happen to be typing at the moment, particularly important for chat. These, of course, were some of the motivating reasons for building React. So Flux and React together provided a much better abstraction for managing state. It allowed us to bring that one-way data flow of the simple PHP apps of the 90s to the dynamic JavaScript clients of today. So of course, now few of us use Flux as it was presented 5 years ago. We've since then, again, continued through this loop of better abstractions, clearer APIs and syntax, and more refined mental models. It led us to Redux, using connect decorators on our React components, thinking of state as reducer functions, and even leveraging functional programming languages like Reason or Elm. React itself has also continued through this loop, adopting class syntax, refining the mental model with component lifecycles, improving the abstraction with React Fiber, and further simplifying syntax with functional components and React hooks. In React, functional components with hooks They feel familiar, like the simple PHP code from 1999 where you just wrote functions that declared your state and then rendered a complete view with templates. So looking back, part of what made LAMP so empowering was just how easy it was to set up and use a MySQL database and create data-driven views. Early simple web apps had pretty easy to follow imperative code. Query your database with SQL, save the result to a variable, render a template with that data. And this worked great in the era where a web app was just a single instance of PHP and MySQL installed on one machine. It was pretty simple, it worked well, and it was pretty easy to maintain. But it really couldn't scale past thousands of users, or to large teams of developers, or to complex data-rich applications. And of course, Facebook needed to do all three of these things, especially as they started to work on new features like Newsfeed. So Newsfeed made data fetching challenging because there weren't performance SQL queries that could get everything needed for a feed of very different kinds of stories. And even if there were, Facebook used memcache to improve performance, and that required cacheable key value pairs. So building Newsfeed with memcache led to the dreaded N+1 problem, attempting to load multiple values from a list of keys, each independently, leading to many blocking queries per page load, each running one at a time. This could be very, very slow. And in fact, early Facebook pages were very, very slow because of this problem. So Facebook built a library called Preparable, intended to solve this problem. A preparable was really just a simple state machine. It was a class instance with a method called prepare, which contained a switch statement. And it's passed an argument that indicates what state it's in. So each step either enqueues some data that should be fetched and then returns true, which means it should later advance to a next state when that data becomes available, or it fetched some additional data and then returned false to indicate that this was the last step after which it could be assumed to be completed. So a preparer collected a list of all the relevant preparables for a page, like one per story in the newsfeed, any notifications you might have, etc., and then called prepare on all of them. When all preparables are stuck waiting for data, a single batch request is sent to memcache for everything requested up to that point. Then it returns and advances the state of each preparable, and it continues like this in a loop until all of the preparables have been completed. This solves the N+1 problem, since now it results in the fewest batched memcache requests, regardless of how complicated the web page was, while still allowing each element of the page to have independent logic. So this allowed Facebook to grow far more complex and data-rich, while maintaining both good performance and a modular, maintainable code base. And this worked pretty well, but as you might suspect, this became a frequent source of bugs for us. It was easy to accidentally forget a return or a break statement in a switch case, or maybe forget a number after a refactor, but we stuck with it and did our best to catch the kinds of issues in code review. And I thought this was super novel and clever until I learned about generator functions. So generators are functions which, rather than running completely top to bottom before returning to the caller, let you yield control back as many times as you like. The caller is then responsible for asking it to carry on by calling a next method. Generators have been around in some form since the 70s, but were more recently popularized by Python in 2001, and then introduced to JavaScript by Mozilla in 2006 as a proposed addition to ES4. And then ES4 was canceled after years of work. Harmony was an effort to bring back some ES4 features, but that was taking forever, and that effort was actually later renamed ES6. So all told, generator functions actually took about a decade from Mozilla's first version to shipping in browsers everywhere. So perhaps unsurprisingly, JavaScript developers at the time were apathetic and had no confidence Harmony would ever ship in browsers, and that people actually used at least. And so they started to take it upon themselves to build tools that allowed them to extend the language before browser support was available. You probably all used or at least heard of one of these, Babel. That was originally called 6 to 5 because it translated ES6 to ES5. But before that project, one of the first of these translators was called Regenerator. So Regenerator specifically transformed generator functions into JavaScript that any browser could run. And this blew my mind. I thought that generators were such a new runtime concept that this couldn't be possible. So of course, I had to learn how it worked. So I wrote a simple generator function, put it through Regenerator, and what came out the other side? A preparable. I learned that a generator function is really just cleaner syntax for describing a state machine, and that it can be translated into exactly the same kind of switch statements that we were already using for preparables. It's almost as if somebody knew about generator functions when they made preparables, and they just didn't tell me. At Facebook, later enhancements to preparables included nested child preparables, handling errors, and adding loops and other more complex state transitions. And these all align exactly with generator function syntax, like yield star, try catch, and just simple plain old control flow, like for and while loops. So generator functions give us syntax for these state machines intended to produce multiple values over time, but preparables are really about complex asynchronous logic that results in a single final state. And that actually aligns much better to a different ES6 feature, promises. So each step in our preparable can kind of be thought of as like a chain of JavaScript promise then callbacks. And in 2012, we spotted an even better fit. C# had introduced async functions, an unholy union between the state machine modeling syntax of generator functions with the asynchronous abstraction of promises, or tasks, as C# had called them. So light bulbs went off, and Facebook, again, extended the PHP syntax to include async and await, and undertook an effort to replace preparables with easier to understand and far less error-prone async functions. These extensions later became the hack programming language, where novel improvements to async programming actually continue to this day. Like literally earlier this year, more cool stuff for async programming. This further clarified the mental model, and later async functions and XHP merged to create Gen XHP, where data fetching and component rendering became co-located. That led to better encapsulation of complex data-driven components. And this final evolution was happening right as we were starting work on GraphQL. And I think you can see the influence of async functions and preparables on both the syntax and execution of GraphQL queries. In fact, we later realized just how important preparable was to GraphQL that we were inspired to create an open source data loader to help solve the same N+1 problem for JavaScript. And the resulting mental model of using Gen XHP inspired front-end engineers at Facebook to build Relay, which borrowed the idea of co-locating data needs with UI components from the server to the client via GraphQL. So multiple times, we cycled through this evolution of better abstractions, clear syntax, and refined mental models, which led to ideas like Gen XHP, GraphQL, Relay, and React Suspense. And this feels familiar to me, like that simple PHP code in 1999 where you just asked for what you needed and then rendered what you wanted. So I think LAMP became so popular in large part because PHP provided a compelling mental model with expressive syntax for building web apps. And 20 years later, it feels like in a way we found ourselves back to where we started. And that's thanks to the steady march forward of better, more powerful abstractions, clearer and more expressive syntax, and improved and refined mental models. And this has helped us build richer, faster, and more complex apps, grow our community to millions, and connect billions of people to the web. And now with the benefit of hindsight, it's actually not that surprising to me that Facebook has been responsible for pursuing a lot of these ideas. It was originally built by people who, like me, learned programming by building stuff for the web in 1999 with the LAMP stack. As Facebook grew in product complexity, popularity, and company size, it encountered these challenges, became frustrated with existing solutions, and drew inspiration from the simplicity of the early web. And that led to better view rendering with XHP, React, and JSX, better state management with one-way data flow, Redux, and now React hooks, and better data fetching with preparable style batching, async functions, GraphQL, and now React Suspense. And I don't think we're anywhere close to done either. There are still plenty of problems to improve upon that could benefit of this progression of better abstractions, syntax, and mental models. Maybe, perhaps, again, inspired by ideas from decades ago. So, as we look to the future, again, we can look to Sir Tim about his dream for the web. Reflecting on this milestone of 30 years, he said, "Today, half of the world is online. It's a moment to celebrate how far we've come, but an opportunity to reflect on how far we have yet to go." The web has become a public square, a library, a doctor's office, a shop, a school, a design studio, an office, a cinema, a bank, and so much more. Of course, with every new feature, every new website, the divide between those who are online and those who are not increases, making it all the more imperative to make the web available for everyone. The web is for everyone, and collectively, we hold the power to change it. It won't be easy, but if we dream a little and work a lot, we might just get the web we want. All of which makes me wonder, what will the web look like in 10 or 20 years from now?